Okay, good morning. So this is the worked examples for pressure. So we'll just get started now. So starting on page 10, we have this cube of side 3 meters is sitting on a bench. If the mass of the cube is 27 kilograms, what is the pressure on the bench? Now, we have a cube 3 meters, and so we need to work out the area that will have. And so a cube 3 meters, it'll have 3 and 3 and 3, although we don't need to use this 3, but the area of the cube, length times base, which is just 3 times 3, which is 9 meters squared. And then pressure is equal to force over area. We'll then have the force is going to be W equals mg, 27 times 9.8. I generally tend not to round my answer in here because I'm going to be using it in a subsequent calculation, and I'll do my final rounding for pressure. So there we go, and substitute the values in. 264.6 over 9 divided by 9 will give me 29.4, and I'm happy with that as it is. And that would be pascals. Moving on. So in question 2 we have a man of mass 70 kilograms, average area is 0.025 meters squared. Calculate the force the man exerts on the ground. So this would be his weight. And we would have 70 kilograms times 9.8. 686 newtons. Calculate the pressure exerted by the man on the ground. So the man is, remember, standing with 2 feet on the ground, and so each foot is 0.025, and so pressure is equal to force over area. And we're going to have his weight, 686, divided by now 2 feet times this. So and that would be 13,720, 13.72 times 10 to the 3. So I'm going to just round that one more place. I'm going to move the decimal point over to here, 1.372. I'm going to call it 1.4 times 10 to the power of 4 pascals. If the man now stands on 1 foot, calculate the pressure at this time. Well, the only difference that's going to happen is that we're going to half the total area, and if you half the total area, then you'll double the pressure. Pressure is doubled as area is halved. Therefore, pressure is equal to this would be 2.7. Okay. So question 3, a man 60 kilograms standing in a block, and we have dimensions of the block, calculate the pressure on the ground. So we'll need to do two calculations first, that is work out his weight, mg 60 times 9.8 588, and secondly we'll calculate the area. Now the block of wood is 0.28 times 0.08, and that would give us 0.0224 meters squared. Now on to pressure, force over area. And we have 2.6 times 10 to the power of 4. Pascals. So for question 4 we have now a woman of mass 60 kilograms stands on one high-heeled shoe. The area of sole in contact with the ground is very small, and so I'm going to expect very high pressure here. Now, so we have the area of sole and we have the area of heel. Calculate pressure on the ground, and so we've got a high-heeled shoe, which would be something like that. If that's our footprint of the high-heeled shoe, so this is the area here and this is the area here. So we add the two areas together. We'll say total area. And that's going to give us 1.2 times 10 to the minus 3 plus 2.5 times 10 to the minus 5 and so that will be 1.225 times 10 to the minus 3 meters squared. And the woman has a mass of 60 kilograms, so her weight, force, mg 60 times 9.8 588 newtons. Pressure is force over area. And so here we have 480 times 10 to the power of 3, so that would be 4.8 times 10 to the power of 5 pascals. So if we compare the two of these, look at this. In question 3 we had a man standing on a block of wood, the man stands on the floor. Now he has exerts a pressure of 1.4 times 10 to the power of 4, whereas in this case we have 4.8 times 10 to the power of 5, and so that's a factor of 10 bigger, so we've got times 10 to the 5 there and times 10 to the 4 there, so there is a factor of 10 times more pressure from the woman standing because of her choice of footwear. Okay, good. Question 5. So, okay, here we go. I've just answered this question. The man in question for the same mass, they did not have the same pressure. Explain why. Well, the man in question 4 was a woman in question 4, and the woman in question 5 is this question 5 here. So this is a bit confused. Let's go with the woman in question 4 and the man in question 3, although possibly it should be question 2 because he's not the same. I've talked about this already. It's a bit silly questions. We should have a little bit more joined up thinking here, Mr. Garrett. Okay, so 60 kilograms. We'll just go with this one and pretend that he's wearing clogs, which blocks of wood, a monoclog. There we go. Oh, there's a monoclog. One single block of wood, 2 holes for your feet, and you can shuffle forward to your heart's content. Available to purchase in your nearest online retailer soon. Yeah, I'm liking it. So we could do a little flower on it. Maybe like a monochrome rainbow. Lovely. Okay, monoclog. It's a thing. Anyway, the man is wearing a monoclog and he has a pressure of 2.6 times 10 to the 4 pascals. The woman wearing high-heeled shoes. And so here we have question 3 with this monoclog. So the man in question 3 and the woman in question 4 have the same mass. They did not have the same pressure. Explain why this is the case. Well, we could say because of the bizarre footwear choice of the man. But we're not going to say that. We're going to say the area of footwear is different. Now, I'm going to just have a wee sidebar over here. So, pressure is equal to force over area. So what this really means is if we just ignore force for a second and then pressure is 1 over area, pressure is going to be directly proportional to the inverse of area. So as area gets bigger, pressure gets smaller, and as area gets smaller, pressure gets bigger. And so I'm going to say that in my answer. The area of the footwear is different as pressure is, now I'm not going to say directly proportional, as pressure is inversely proportional to area as the area is smaller for the women, the pressure is greater. Done. Explain why it's necessary to wear snowshoes to walk over soft snow. Here we go. As pressure is inversely proportional to area. larger the area, the lower the pressure. Snowshoe has a large area. Okay, I cut a wee bit, you didn't want to see me write all of this. So what I've said is pressure is inversely proportional to area. The larger area, the lower the pressure. A snowshoe has a large area and therefore a low pressure. With a low pressure, the wearer will not sink into the snow as much. Fantastic. Okay, so that is the pressure questions, and thank you.